1, so equal to 1. And S4 actually is U1 plus U2 plus U3 plus U4. So here actually is 1 minus 1 plus 1 minus 1. Yeah? So here is 1 minus 1 and plus 1 minus 1. So this is actually equal to 0. Equal to 0. So actually we can go on. Okay, go on. Here is S5. S5 is U1 plus U2 plus U3 plus U4 actually and plus U5. Okay. So actually here because here this one U1 plus 2U4 actually is S4. So here actually we can write it in this form. Okay. S4 plus U5. Yeah. S4 is what? Is 0. U5 is what? U5 is 1. Yeah. So here actually 0 plus 1, so equal to 1. And S6 is U1 plus U5 plus U6. So the first 5 terms actually is S5. So S5 plus U6. So S5 is 1. U6 is what? Minus 1. Yeah. So 1 plus minus 1. So 0. So actually we can go on. Okay. We can go on. So it's easy to see that S1 1. S3 is also 1. S5 is 1. Yeah. And S2 0. S4 0. S6 0. So from here, we can see the even number, okay? The odd number, okay? The odd number terms. The odd number terms actually is 1, yeah? So here means the odd number. So the odd number terms. So odd number terms here means S2n plus 1. Okay, this is actually equal to what? Equal to 1, yeah? And the even number terms, okay, the even number terms, here you can see S2 0, S4 0, S6 0. So we can see S2n equal to 0, yeah? So from here we can see the odd number terms is 1, the even number terms is 0. So here means what? Here means this. The limit of odd number terms will converge to 1. And the even number terms will converge to 0. So these two limits actually is not the same, yeah? Not the same. So here means what? Here means this converge, okay? This sequence S1, S2, S3, and go on, okay? So this sequence actually is diverge, yeah? So this sequence is diverge, so here means what? So here means this series, this infinite series is also diverge. So here means k equal to 1 to plus infinity minus 1 to the power k plus 1. This series, okay, this series is diverge. Okay, is diverge. Okay. When n equal to 1?
Means n is from 0, right?
N no, f from 0. N from 0, yeah. F from 0, so 2 times 0 plus 1. So S1 equal to 1.
How to calculate this?
So it's so easy to see here because you can see because this term is 1 minus 1 plus 1 minus 1 plus 1 minus 1. So here we can see 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1. Go on. So we can see it's easy. When when we add the second, okay, the first two or the first four, we have the same. We have 1, 1, and we have 1 minus 1, yeah? So here means the S2n actually is 0, yeah? And if we add the order, okay, if we add the order terms, so here, for example, for here F3 or S3 here, this is, so we can see we have 2, 1, but we just have 1 minus 1, yeah? So the sum actually is 1. And if we have the 5, okay, we have 5 here. So 5 here actually we have 1, the first one, the second one, the third one. We have the third, we have 3, 1, but we just have 2 minus 1, yeah. So the sum actually is 1. So I think it's easy to see here because the 1 minus 1 plus 1 minus 1 plus 1 minus 1. I think it's easy to see it, yeah? So now we will introduce three series. The first means the geometric series. The geometric series. So the first, the geometric series. So this series, how to define the geometric series? So the geometric series actually is in this term or in this form. Sigma A times R to the power K, okay, to the power K. K runs from 1 to plus infinity. So geometric series actually is in this term, in this form, okay, in this form. Here actually is A not equal to 0, A not equal to 0, and R actually we call it what? We call it the ratio, okay, the ratio RATIO. So the ratio A means A not equal to 0, okay, non-zero is non-zero constant. So the geometric series is in this form. The geometry term is AR to the power K, okay, A times R to the power K. So we can write it in this form. So here, when K equal, K runs from 0, okay, K runs from 0. K runs from 0, so when K equal to 0, the first term actually is A.
Yes.
When K equal to 1, so actually it's AR, yeah? And when K equal to 2, so here actually is AR square, so plus AR square. And when K equal to 3, so here is AR to the power 3, okay? So here is AR to the power 3, so and go on. When K equal to K, so here is AR to the power K, go on, okay? So it's actually in this form, okay, in this form. So from here we can see the first term is A, it's a non-zero, okay? So why we need A non-zero? Because when A equal to 0, actually this every term is 0, yeah? So it's trivial, okay, it's trivial. When A equal to 0, each term is 0, okay? Each term is 0, so it's trivial, okay? So we just consider the A not equal to 0, non-zero constant, okay? And the R means the ratio, so here, the ratio means the second term, actually it's the first term times R, yeah? AR actually equal to A times R, yeah? The third term actually is the second term times R, yeah? The second term is AR times R, actually, so it's AR square. And the first term actually equal to the third term times r. Yeah. So actually for this geometric series, the figure, okay, the most important figure actually is the last term of the last term by the first term, okay? So the means the nth term, okay? So the nth term actually equal to what? Actually equal to the n minus 1th term. N minus 1th term times r, yeah?
Yes.
For this geometric series, okay? For this geometric series means the nth term actually equal to the n minus 1th term times r, okay? Times r. So for example, for here, now let's see the first 1 plus 2 plus 4 plus 8 plus 16 and plus go on. Here is 2 to the k power k. So for this one, for this series is a geometric series or no? Or no? This series is a geometric series or no? Or not? So we can see the first term, the second term actually equal to the first term times r times 2, yeah? And the third term equal to the second term times 2. The fourth term, 8, equal to the third term, 4 times 2, yeah? And the fifth term, 16 equal to 8 times 2, yeah? So it's easy to see this actually is a geometric series. A actually equal to what? A actually is here, yeah? So A equal to 1 and R equal to what? R equal to 2, yeah? R equal to 2. And now for the second here, 3 by 10, the first. 3 by 10 plus 3 by 10 square plus 3 by 10 cube plus 3 by 10 to the fourth power and go on. Here is 3 by 10 to the kth power. Go on, okay? So this is also a series. So this series is a geometric series or not? So now we can see the second term equal to the first term times what? 1 by 10, yeah? And the third term actually equal to the second term times 1 by 10. The fourth term actually equal to the third term times 1 by 10. So of course, so it's also a geometric series. R equal to what? R equal to 1 by 10 and A equal to what? A equal to the first term here, yeah? So 3 by 10, okay? So this is the second series. Now we see another series here. 1 by 2 minus 1 by 4 and plus 1 by 8 and minus 1 by 16 and plus minus 1 to the power k plus 1 times 1 by 2 to the power k, okay? To the power k. This is the general term, okay? General term and the plus. So the general term actually is minus 1 to the power k plus 1 times 1 by 2 to the power k, okay, to the power k. So for this one is a geometric series or not? So now we can see the first term is 1 by 2. The second term is minus 1 by 4. So minus 1 by 4 equal to 1 by 2 times what? Minus half, yeah? So minus 1 by 4 equal to 1 by 2 half times minus half. And the third term is 1 by 8. 1 by 8 equal to minus 1 by 4 times what? Minus half. Yeah. And the fourth term minus 1 by 16 actually equal to 1 by 8 times what? Minus half. So it's easy to see R actually equal to what? Minus half. And A equal to what? A equal to half. Yeah. So it's also a geometric series. Okay, it's also a geometric series. So here now. So this is the geometric series. This is the geometric series. Geometric series actually is in this term, or in this form, okay? In this form. Sigma A times R to the power K, where K runs from 0 to plus infinity. So now we have a question. So for this one, this series is converge or diverge? Is converge or diverge? So now we have a question for this one, for this geometric series. Is it converge or diverge? So now, is it converge or diverge? We just need to see the sequence of partial sums. Is it converge or diverge? Is it converge or diverge? So now we can see the sequence of the partial sums. Now for this one, so here this is the sigma k runs from 0 to plus infinity. A times R to the power K. So this is equal to A plus AR plus AR squared plus AR cubed. So go on. Here is AR to the power K. Go on. So this is sequence. Yeah. So now we need to see the partial sums. The partial sum sequence. So S1 equal to what? S1 equal to the first, yeah, equal to A, yeah. And S2 equal to what? S2 equal to A plus AR, yeah. A plus AR. So, and go on here. S3 equal to what? S3 equal to A plus AR and plus AR cubed, yeah. And now, so we go. Oh no, I'm sorry. It's square. Okay, so the square. So here go on. So here Sn equal to what? Sn. So Sn should equal to the first nth term. Yeah, the sum of the first n terms. So Sn should be equal to A plus AR plus AR squared plus. Here is AR what? AR what power here?
N minus 1.
N minus 1 power, yeah? So N minus 1 power. So this is the finite remaining terms, okay? So how can we find the explanation of Sn? So Sn equal to A plus AR plus AR squared plus AR n minus 1 power. So what's the previous term? So actually we can write it another term. So AR here, we write it AR minus 2 power plus AR minus 1 power. Yeah? So now if we times R on both sides, okay? We times R on both sides. So we have what? R times Sn equal to what? So R times Sn, so here R times Sn, so the first term times R, yeah? So the first term times R, so here actually is AR, yeah? The second term times R. The second term is AR times R, so AR squared. So here plus AR squared. And the third term, AR squared times R. So it's what? AR cubed. Yeah? And go on here. Here is AR n minus 2 power times R. So here is what? Here is AR n minus 1 power. Yeah.
Yes.
And the last term times R. So here is AR n minus 1 power times R is what?
AR to the power n. Oh, A.
So here should be AR to the nth power. Yeah, to the nth power. So now we can see here. Here we have AR, here we have AR, here AR square, here AR square. Here is AR n minus 1 power, here is AR n minus 1 power. So now if we find the difference of the left hand side should be equal to the difference of the right hand side. Yeah. So from here we have the left hand side minus the left hand side. So here should be 1 minus R Sn. This is the difference of the left hand side. Yeah. This is the difference of the left hand side. And for the right hand side, so we can see this part. Okay, this part. And this part. These two parts, they are the same. Yeah. They are the same. So these two parts, actually the difference of these two parts is 0. So here just have here is A minus AR to the nth power. So here should be A minus AR to the nth power. Okay, to the nth power. So this is equal to what? So this is equal to A times 1 minus R to the nth power. Okay, A times 1 minus R to the nth power. So from here it's easy to see Sn equal to what? So here Sn should be equal to, here we divided. Okay, we divided. So of course here R not equal to 1. Okay, here R not equal to 1. Here R not equal to 1. So here Sn actually equal to A times 1 minus R to the nth power by 1 minus R. So Sn, so we find the expression of Sn. We find the expression of Sn here equal to A times 1 minus R to the nth power by 1 minus R. So this is the expression. So Sn. So now we need to find the limit of Sn. The limit of Sn. So the limit of Sn equal to what? So here now limit Sn when n approaches plus infinity, this is equal to what? So now actually is here. So this part we can write it in this form. Okay, here times A by 1 minus R times 1 minus R to the nth power. Yeah. So we find this limit. This limit actually is this limit. The limit of the right hand side. So limit n approaches plus infinity. Here is A by 1 minus R. Here is 1 minus R to the nth power. Yeah. So now we can see A by 1 minus R is a constant. The constant can move through the limit sign. So this is equal to what? So this is actually equal to A by 1 minus R. A by 1 minus R, here is the limit. N approaches plus infinity, here is 1 minus R to the nth power. Yeah? So now, so this is the limit of a difference equal to the difference of the limit. Yeah? Equal to the difference of the limit. So this part actually we can write it in this form. Okay, so this is equal to what? So this is equal to A by 1 minus R. Here is the limit of 1 is 1. Yeah?
Yes.
1 minus limit R to the nth power n approaches plus infinity. So we just need to find this limit. So the limit of AR, the limit of R to the nth power. So this limit is equal to what? So actually we should to see the value of R. The value of R. If R Now, so this is actually equal to what? So we just need to see this case, okay? Here, when the absolute value of r less than 1, and when the absolute value of r greater than 1, okay, we need to see these two cases. These two cases. The first case, when r, okay, when r the absolute value of r less than 1, so limit of r to the s power, this limit is what? So for example, we can see limit. For example, we see r equal to half. We see r equal to half. So when n approaches plus infinity, half to the s power approaches what?
0.
0, yeah? So here in this case, this is actually 0. So here is 1 minus 0 times here. So the result should be a by 1 minus r. So this is the first. So now when the absolute value of r greater than 1, for example, r equal to 2. So when r equal to 2, so now we can see 2 to the s power, 2 to the s power, when n approaches plus infinity, this limit is what? When n approaches plus infinity, 2 to the s power approaches what? Plus infinity, yeah. So here is plus infinity. Yeah, so this is plus infinity. So here means plus infinity means this is diverge, okay? So it's diverge. So in this case, actually it's diverge. Diverge. So now, so we have a question. So here is the absolute value of r less than 1 or greater than 1. So now, what about r, the absolute value of r equal to 1? So the absolute value of r equal to 1. The absolute value of r equal to 1. 0. So here, now, so the absolute value of r equal to 1, actually we have two cases. The first is r equal to 1. The second is r equal to minus 1. Yeah? So now we can see when r equal to 1, when r equal to 1, when r equal to 1, we can see this series actually is what? When r equal to 1, this series actually is a plus a plus a plus a plus go on, yeah? Here because a not equal to 0, yeah? So this a plus a plus a plus a, so this will go to what? So here we need, for this one, okay, for this series, it's easy to see Sn equal to what? Sn means the sum of the n term, yeah? Is Na, yeah? Na, so n approaches plus infinity, Na will approaches what? Plus infinity or minus infinity, yeah? This is decided to the positive or negative of A. If A is positive, Na will approaches plus infinity. If A is negative, Na will approaches minus infinity, yeah? So, plus infinity or minus infinity, here means is diverge, yeah? Diverge. So this is the first case. The second case is when r equal to minus 1. When r equal to minus 1, so here, when r equal to minus 1, so here is what? A equal to minus 1, so here actually is a minus a plus a minus a plus a minus a plus a minus a, go on, yeah? Yeah? So this series is converge or diverge. So actually this is, you let a equal to 1. So here is 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1. Yeah? So the first example, we say that this series is converge or diverge. Diverge, yeah? So here means when r equal to 1 or r equal to minus 1, okay? The geometric series is diverge. Is diverge. Is diverge. So here, because this case is diverge, this case is diverge. So these two cases we can write it in one case. One case means that R greater than, or the absolute value of R greater than or equal to 1 diverge. Okay? So this is the result. So this is the result. You should to remember it. Okay? When the absolute value of R less than 1, the geometric series actually is converges to A by 1 minus R. And the absolute value of R greater than or equal to 1. The geometric series is diverge. So we can write it in a series term. Okay, we can write it in a series term. So for this one, the geometric series so we have this result. Geometric series sigma k runs from 0 to plus infinity, a r to the power k. Okay, a not equal to 0 for this one. Okay, for this one is converge if the absolute value of r less than 1. Okay, and diverge if the absolute value of r greater than or equal to 1. Okay, and equal to 1. And if the series converge, okay, if the series converges, then the sum is sigma a r to the k's power where k runs from 0 to plus infinity. Okay, so here is k runs from 0. Okay, k runs from 0. So this is equal to what? This is equal to a by 1 minus r. Okay, 1 minus r. So here means this is the first term. Okay, the first term by 1 minus the ratio. Okay. Do you have any question? The first term by 1 minus the ratio. Okay. So this is the result. So no, we have a break. Okay, 10 minutes.
네?
하나만 플리즈 내드릴까?